Okay. All right, so let's start. But I was expecting the number to, you said you are 15 in the class, right?
Yes, sir.
So what is happening? Some people are not here.
So they will join.
Okay. So can we start?
Yes, sir.
All right, so today we want to start our lectures. So we're starting with quality management, as I told you last week. So this will be the first slides that we'll be discussing. Actually, I'm done with the preparation of the course model, and we're going through, so hopefully to be available by the end of, or let's say next week, it will be available. I've captured all the things that are in this slide and other materials in the course model for you. So what I'm going to present in this slides, you get them in the course model if you are ready, and they are well explained in the model. So then you'll be fine. Okay, so in this slides, we want to look at software quality. What is it? When we talk about quality, what is it about? And then software standards. Then we'll look at reviews and inspections. Then we'll look at quality management and agile development. Then the last subtopic will be software measurement. So these are the subtopics we'll be looking at in the under quality management. So if you take your module, you see that these topics are actually treated as sessions. So you have session 1, session 2 in that order. All right. So if we're looking at quality, we can see quality as a session, software standard as a session, reviews and inspection as a session, and that is how it is. So why should we be thinking about quality? Software quality management. What is management about? When we talk about quality management, okay, I think that there's a slide that I should have presented that slide before this one. Okay, but let me continue. I will try to chip in that as I continue. Okay, so why should we be interested in software quality? The reason is that when developers are working on a project, they go through phases of software development. Okay, so from your previous studies, you learned that you first have to plan, okay? So the planning stage, and then you move to do requirements gathering, okay? Then after gathering the requirements, you have your requirement specifications, then you design the system, okay? After designing the system, you go ahead to implement it. This is where coding comes in. Okay, so after implementation, then you test, right? So these are the stages that you have to go through if you're developing a system. Okay. Now, this all happens during the software development at every stage of the process. You realize that the developers, because they are human beings, they introduce errors into the system. So at this stage, during the planning, there may be mistakes, there may be defects with the plan, okay? And then at the requirement gathering stage, they may introduce errors into the requirement gathering. Similarly, if they are working on the designing, the designs will have errors in them. And it continues in that fashion. Now, one thing we also need to know is that the error that is introduced at the previous stages are actually carried to the next stage. For example, the ones that are introduced at the planning stage are propagated to the requirement gathering stage. Then from the requirement gathering stage, the errors that were carried from the planning stage to the requirement gathering stage, in addition to the ones introduced at the requirement gathering stage, are carried forward, in fact, propagated to the design stage. And as I explained, at the design stage, they will introduce additional errors. And it continues like that. So these ones will also be propagated to the implementation stage. And we know at the implementation stage, whilst they are coding, they will make mistakes in the code and all that. So eventually, what will happen is that there will be accumulation of errors in the process of developing a system. So all these errors, defects that are introduced at the various stages are accumulated. So by the time you get to the stage which we call testing stage, where you have to test and debug and all those things, you would have accumulated a lot of errors, defects in the system. But you realize that if you have to accumulate all these errors just for you to get to the testing stage and say you want to test and get rid of all those errors, it becomes very difficult. In fact, increasingly difficult. And because of that, you are not able to detect a lot of errors in the system because some of them will be hiding. All right, so this is all happens during the system development process. So there are errors that are introduced, and these errors are accumulated and then propagated to the next stage of the system development. And so in this course, software reliability and quality management, we want to study the strategies, the practices that we can adopt or we can practice so that whilst we are developing the system, whilst you are working on a project and you are going through the various stages, we'll minimize the errors that are introduced into the system. And we'll also detect and remove the residual errors that will be in the system. Of course, we cannot remove all the errors. There will be some that will be hiding somewhere. And so what we have to do, in addition to minimizing the error introduction, trying to detect and remove, we also have to design the systems such that if a fault occurs, it will not lead to the system failure. All right, so these are some of the things we'll be discussing in this course. All right, so normally I use a slide to give this motivation, but because I've started with the main slides, so I needed to give you this background information before I start explaining what quality management is about. Is there any question you want to ask about what I just explained? How errors get into the system? Is there any question or comment? Hello?
are no questions yet.
No
Okay.
questions yet, sir.
Yeah, let me be hearing from you because I'm not seeing you face to face. So let's interact, okay? So that I will know that you are actually following the discussion.
Yes.
All
Okay,
right.
so this is what happens in the system development processes where people are working and they make mistakes, and these mistakes sometimes leads to error effect in the system. So why should we be interested in getting these errors removed? If we don't, the errors that are in the system will cause the system to fail. Okay. Now, there are basically two types of systems that we'll be looking at. We'll look at critical systems or applications and then non-critical systems. If you looking at critical systems, they are systems that if a failure occurs, it can lead to serious consequences. For example, we can talk about systems that are used at the hospital, medical systems. We can also talk about systems that are used in the telecommunication industry and then power industry. Then we can also look at aeronautics systems or aerospace systems, systems that are used to manage aircraft. Okay. Now, systems like that are considered as critical systems. Why critical? Because if a failure should occur, it will lead to serious consequences. Therefore, systems like that have high reliability requirement. Okay, that means that they don't want systems like that to fail. So if you are developing systems that will be used in industries like that, you have to make sure that there are no errors in the system that will cause it to fail. Okay, so those are some of the things we'll be discussing. However, if you're talking about non-critical systems where a failure may not necessarily cause serious consequences, then they may allow some level of failures, okay? They may allow some level of failures because a failure may not lead to serious consequences. Okay, so with this at the back of our mind, we need to now think about how do we then get rid of errors? And how do we ensure that the system that is developed is actually meeting the requirements, is meeting the specifications? Then if we have to ensure that, then we need to manage the development process, okay, in terms of quality. So that is why we need quality management. So when we talk about software quality management, our concern will be to ensure that the required level of quality that is expected of the system is achieved, or the required level of quality is achieved in the software product. But for us to be able to do that, I want us to look at this scenario. Let's say we are working in a company, a software development company. And we know that in the company, you have management, you have people working at the middle level, and then there are people who are actually doing the job. Okay, so let's have that in mind. So we're saying that when it comes to assuring the quality in the software products, we have three principal concerns. This has to do with the levels. So we have the first level is the organizational level. Then the second level and the third level are the project level. So we have the organizational level, project level, and project level. Now, at the organizational level, quality management is about establishing a framework of organizational processes and standards. So that means that at the organizational level, management of the software development company will have a framework of the processes and standards that are supposed to be used to develop high quality software. Okay. Now, these organizational processes and standards will now be applied at the project level. So at the project level, the project managers will now apply these organizational processes and standards to specific quality processes. And they will have to check that whatever they are doing is actually following the framework that has been established at the organizational level. Again, at the project level, the quality management is also concerned with establishing a quality plan for a project. That means that the project managers and the team working on the project will have to come up with a quality plan for a specific project. And in this quality plan, they will need to specify the goals that they want to achieve for that particular product they are developing. So the goals will be stated clearly in the quality plan. So what are the quality management activities? The quality management activity provide independent check for the software development processes. The quality management process checks the project deliverables to ensure that they are consistent with the organizational standards and goals. Let me explain that. You see, I just explained that at the various stages of the software development processes, we have what we call deliverables. For example, at the planning stage, you produce a plan that you're going to follow to develop the system. So that plan will become a deliverable at the stage of the planning. That is all you produce as your artifact or deliverable. Then when you're working on requirement gathering, you come up with your requirement specifications that will guide the design. So your requirement specification document will become the artifact or the deliverable that you're going to produce. The same applies to designing stage. At the design stage, you have to design the system using the various diagrams, for example, class diagrams, sequence diagrams, use case diagrams, all those things, and your database schema, all those things are considered as deliverables. And so at every stage of the project, you have something to deliver. So if the quality team wants to check for quality, what they do is that they go in for these deliverables and they check them against the standards and the goals that are clearly stated in the quality plan, okay, for that project. Here, we need to understand that the development team, that is the team working on the project, developing the system, should be different from the team that will be checking the deliverables for quality attributes. Why should it be so? We want the quality team to be independent from the development team so that they can have objective assessment of the deliverables to be sure that whatever is produced is actually meeting the standards and the goals that have been set for the project. Okay, so the quality team should be independent from the development team. So this is how it looks like. So let's look at the top one. You see these two processes. The top one is the software development process, as you can see. And the bottom one is the quality management process. So the D1, D2, D3, D4, D5 you are seeing are the deliverables at the various stages. So we can say D1 is the plan, D2 is the requirement specification, D3 is the designs, and D4 is maybe the code, and D5 is the test cases and test plans and things like that. Okay. So what it means is that if the quality team wants to be sure that whatever is produced is meeting the standards and the goals, they'll have to review them. Okay. All these deliverables will have to be reviewed. But before the team start looking at this deliverable, or before the development team start producing the deliverables, the quality team has to start work first. Okay, so they start first by getting their standards and procedures ready, as you can see. So the standards and procedures will have to be written and documented first. Then, as I said, the quality plan should be written. And in this quality plan, the goals will be clearly stated. So once the quality plan is ready, the development team can now start work and then start producing the deliverables. So you see that the first deliverable actually is in after the quality plan has been written. So now once the deliverables come in, quality team can do quality review of the deliverables and produce their reports. So that is why you have all these reviews taking place at the end of every stage of the development processes. Okay, I hope this diagram has actually made it clear and with the explanation.
Yes, sir.
Is it okay? So if it's clear, then we can continue. Now, so what is quality planning? As I said, there should be a quality plan, and the plan should have the goals and the standard that the team will have to work towards. So the quality plan set out the desired product qualities and how these are assessed, and it should define the most significant quality attributes. So that in the plan you have the quality attributes that you're actually looking for in the product stated. And then in the plan, the project team will also have to state how the quality team will have to state how they are going to assess the product for those quality attributes. Why is it so? Because if you don't have the quality attributes stated, when the system is developed, it will be difficult for you to know whether the system is actually a quality product or not. So the quality attributes now will be the goals that you are looking for, you want to achieve in the system. And you should also state how you are going to assess the system, the product for those attributes. So the plan should define the quality assessment process, and it should set out which organizational standard that will be applied. When necessary, define new standards that will be used. Okay, so the plan should look like this. You have a quality plan structure, and in the structure, you want not talk about the product. So product introduction, and then the product plans process that will be used to develop the system. You have to describe them. So you have process description. Then you list the quality goals, and then risk and risk management. Now, it's important to understand that anytime you're working on a software project, there are risks that you will encounter. So you need to identify the risk even before the work starts, and also state how you're going to manage those risks. Okay, these are very important, and the risk can come in any form. For example, if you have to work within, let's say, 2 weeks, and you don't manage the project well, you don't go by the plans, you end up actually more than 2 weeks. That is a risk. Why should that be a risk? Because there will be cost overrun. The budget that has been allocated for the project, 2 weeks project. Now, if you go to work over 2 weeks, that means that the management will have to get extra fund to be able to complete that project. So that is a risk. And there's also a risk of the user or the client rejecting the system that is developed. Okay. If the system is not meeting the quality standard, the user may reject the system. So at this stage, when you're planning to produce the system, you need to consider all those risks that are associated with the project, and also document how you're going to manage those risks. The plan should not be too long. It should be short. It should be succinct document. If it is too long, people will not have time to read it. Okay, so basically, that is all we're looking at. Now, so once this plan is in place, then the development team can start producing, because now they know the goals, they know the standards, they know the risk and how to manage those risks, so they can start work and produce the deliverables. Then the review can take place as and when a deliverable has been released. Okay, the scope of quality management. Here, the scope, we're looking at the size of the project or the system. So quality management is particularly important for large, complex systems. And when it comes to working on large, complex systems, you want to have proper quality documentation. And this quality documentation will have to record progress and support continuity of development as the new development team or as development team changes. What am I trying to say here? You see, if you're working on a project that is large and complex, you need proper documentation. If you don't have documentation on what you are doing in terms of what is implemented, the progress you are making, any activity that has been done and what has been produced, things are not properly documented. It gets to a point, people will not follow whatever is happening. In fact, people will not understand whatever is happening. So it's important to document. Apart from that, a project that will take, let's say, 6 months, a year to finish, it's possible that some people may leave and then new hands will come in. And let's say that happens, and then you get new people to join the team. How would the new guys follow whatever the team has been doing without documentation? It will be difficult. Okay. So if there are documentations, then these new guys who have joined the team can actually read the documents, know the processes that are being used, know the goals in the quality plan, and then be able to follow whatever they are doing and then participate in the teams. So these are very important things that you have to do if you're working on a project that is large and the system is complex. However, if you're working on a system that is smaller, then detailed documentation may not be necessary. Okay, so in cases like that, you may want to have what we call quality culture. So you rather want to focus on establishing quality culture. So what is quality culture? There are practices that if you implement or you adopt, you are able to ensure that the deliverables that you are producing at the end of every stage of the system development meets the standards or is conforming to specification. So those practices are referred to as quality culture. So culture, I can describe it or define it as the way things are done in a particular setting or environment. So in a system development organization, the practices, the way they go about their requirement gathering, the way they write their codes, the way they design their systems, all those things can be referred to as their culture. Okay, so if we talk about quality culture, we say that quality practices should be introduced into their culture, how they go about their work. And once everybody is part and parcel of the team and they understand that this is how we have to do it in order to get quality products, then they will be responsible for the quality of the work that they are actually doing. And that is what we are referring to as quality culture. Later, we'll see, as we continue, we'll see that this quality culture is actually used by agile guys, agile teams. When they are working on their projects, they don't deal with detailed documentation. They don't spend time documenting things, but rather focus on producing working software, practicing quality culture. Okay, so the techniques have to evolve when agile development is in use. That is what I was trying to explain. So now let's begin to look at software quality. When we say quality, what is it? How do we describe software quality? And when can we say that a system is a quality one or is not a quality one? So quality, in its simple terms, means that a product should meet its specification. What are we saying here? Now, you realize from the previous discussion that if you're going to develop a system, one of the things you have to do is to get the specification of the system. In other words, you gather requirements about the system using various means. For example, you can interview the users, you can do your own observation about existing system. You can also use questionnaire, okay? Talk to people about the system that you want to build. All you want is to gather information about the system in terms of the requirements. So once you have the requirements, you need to put it together in such a way that you can implement it in your design. So that will be the system or requirement specification. Okay. Now, this requirement specification will help you to design the system. Okay. So if you don't have the requirement specification, you can't design the system. That is why you need to do your system analysis first, okay, to get the requirement specification. Then you go ahead to design. Now, this requirement specification is not only used to design the system, it also becomes the basis for determining the quality of the system, because this is where the specification is. So once the system is developed, you want to validate it using the specification. In other words, you want to check and see that the product is actually conforming to the specification. And where is the specification? It's in the requirement specification. So we want to define the quality and say that if a system meets or a product meets its specification, then that product is a quality one. All right? But there's a problem with this definition. So this is problematical for software systems. Why am I saying so? The reasons are here. Okay, but let me explain them so you can understand. First of all, you know we have basically two types of requirements. We have functional requirements and non-functional requirements. Okay, functional and non-functional. Even if you are looking at the functional requirements, okay, some of them are things that are requirements that will satisfy the developers themselves. Okay. And there are some that will satisfy the users of the system. But I know if you're working on a project, your goal should be satisfying the users of the system. Okay, but when the guys are developing a system, they are also interested in some of the quality attributes. For example, they are interested in maintainability, reusability of the system that they are building. Okay, whilst the users will be interested in things like efficiency, reliability, and related attributes. Okay, so what is the issue here? The challenge is that whilst they are working on the system that they are building, the developers may tend to satisfy themselves in terms of the quality attributes that they want to achieve at the expense of meeting the requirements of the users in terms of the quality attributes. Apart from that, you also come to realize that some of these quality attributes are conflicting in the sense that once you try to satisfy or you try to achieve some of the quality attributes, you end up compromising on others. Okay, so this is what we refer to as tension. There's a tension between customer quality requirements and developer quality requirements. Okay, so we have quality attributes. Some are for the developers themselves and some are for the users or people who will be using the system. But when they are developing the system, they tend to focus on the requirements that will satisfy the developers themselves instead of focusing on the ones that will satisfy the users of the system. So this refers to the tension we're looking at. Some quality requirements are difficult to specify in an ambiguous way. Software specifications are usually incomplete and often inconsistent. Let me explain this one. Still, what are we talking about? We're saying that if you define quality in terms of a product meeting specification, it's problematic. Problematic because the requirements that is used as a basis to determine the quality of the system may itself not be complete. In other words, the requirement is incomplete and often inconsistent. Why are we saying so? From practice, you realize that if you are going to build a system, and at the initial stage, you conceiving, or the conception stage, you try to have idea about the kind of functionalities you want in the system, the features you want to implement, and all those things. At the initial stage, you are not likely to have full, I mean, have a complete ideas about the kind of systems you want to build. Okay, so you have some of the features that you want to work with, but then you don't have all. So the ones that you have, those are the ones that you're going to document as the requirements of the system. Then later, as you are working on the project, new ideas will be coming up, and then you are modifying the system, introducing new features and all that. All right, so that is what happens in reality. So we're saying that if that is the case, then the requirement may not be complete and can be inconsistent. Therefore, if you're going to use that same requirement specification that is incomplete and inconsistent to determine the quality of the system, then there's a problem with their definition, okay? Because a system may meet the specification of the requirements, but from quality perspective may fall short, okay, of what the users are actually expecting in the system. So if that is the case, then we don't have to think about defining a product that meets the specification as a quality one. We should rather think about how fit the system is in terms of what is supposed to be used for, the purpose. Okay? So we need to focus on fitness for purpose rather than thinking about the system conforming to specification. All right, so this is what we're trying to say over here. If there's any question you have to ask, I'll pause and give you the opportunity to ask, or any contribution or comments, because this is very important. This part of the slide is very important. It helps us to understand what is going on, how we can look at quality. When do you say this a system is a quality one, and when do you say it's not a quality one? How do you define quality? That is what we are trying to look at here. Originally, you want to use the requirement specification to determine the quality. But as I said, the requirement specification may be, using it may be problematic because one, there's always tension between customer quality requirement and that of the developers. Also, the requirement itself may be incomplete and inconsistent. Therefore, if you use it, you may have the system conforming, but may not be fit for purpose, or may not be able to meet the expectations of the users. Therefore, we need to think about how to define quality in terms of how fit the system is for what it's supposed to do. So that is fitness for purpose, okay? So we rather want to focus on fitness for purpose rather than the system conforming to specification. Any question, comment? Hello, Emmanuel. Emmanuel, do you have any comments or question?
Not really, sir.
Okay, Prince, how about you? Prince Carl. Prince, any question? Prince, are you with us? Is Prince here? Collins. Collins, how about you? Do you have any question? Collins, are you here? Collins. Sarah.
Hello.
Yeah, Collins, I'm asking if you have any question.
No, please.
Okay. How about Sayram? Sayram, do you have any question, comments?
Sir, please, for now, no.
Okay. But are you following the discussion?
Yes, please.
Okay. George Kwame.
No question for now.
Okay. So
Yes.
does it mean you are getting everything that I'm explaining?
Yes, it's so relatable, sir.
Okay. All right. Then we can continue. Okay, so now we're saying that we should rather think about how fit the system is for purpose. So if that is the case, how do we define fitness for purpose? How can we say a system is fit for purpose? So that's what we want to look at. So a software is fit for purpose if we can answer yes to this question. So the first one is saying that the software should be properly tested. So they will ask you, has the software been properly tested? If you say yes, then they'll ask, is the software sufficiently dependable? That means that after you've tested the software, you should test the software for the dependability. In actual fact, dependability has to do with reliability. Okay. So it's a way of asking whether you have tested it for reliability or dependability. So is the software sufficiently dependable to be put into use? They say yes, it is dependable. Is the performance of the software acceptable for use, for normal usage or normal use? Yes. Now that means that you have to test the system for performance. You test it for dependability, you test it for performance. Then they will ask you, is the software usable? Meaning you have to test it for usability. Then, is the software well structured and understandable? Yes. You have to make sure the system is well structured and is understandable. Then they will ask, have programming and documentation standards be followed in the development process? Yes. During the development process, programming and documentation standards have been followed. Once you can say yes, in fact, you have done all these things, we believe that the system is fit for purpose. Okay, so that is that about fitness for purpose. But let me explain something here. Maybe we'll see it as we continue, but it just came up. Let me drop it before I forget. It has to do with the relationship between the process that is used to develop a system and then the product itself. Now, in this class, you come to understand that when we talk about quality, it's not only about the products. We should also think about the process. Why is it so? It is so because if the process that you use to develop the system is not a quality one, then the product that comes out at the end of the day will also not be a quality product. So that is why we need to focus on the process. The process is very important because we believe if the process is good, for example, as the question is asking, programming and documentation standards. If you use the standards that have been stated in the quality plan and you follow the programming standards, then we want to believe that what will come out as the product will be a quality one. So it's important to also look at the process quality attribute and also the product quality attribute. We'll see it shortly when we get there. So non-functional characteristics. You see some of the attributes that I have just mentioned in terms of the fitness for purpose, like performance, dependability, understandability, or a system is understandable. Some of these attributes are what we call non-functional characteristics. Just like we talk about functional requirements and non-functional requirements. When it comes to the quality attributes, some of them are functional and some are non-functional. Okay. So for functional ones, we can look at them in terms of what the users want and what the developers actually want in the system. However, when it comes to non-functional ones, it's difficult to assess them because they are subjective quality attributes. Why do we say they are subjective quality attributes? They are subjective quality attributes because to say a system is quality is a quality one in terms of this non-functional characteristics is based on user experience. In other words, we have different users. Some are novices, some have experiences, and as they interact with the system, as they use the system, their perception about the system will be different because their levels of experience are different. Okay, so one person may have experience with the system that will give him his perception about the system, whether it's a quality one or not. Another person will have different perception based on the experience they have. Because of that, we say these quality attributes, the non-functional ones, they are subjective. Subjective because it depends on individuals and how they use the system, the experience they have with the system. Okay. So, yeah, basically that is what I wanted to say about this part. So what it means is that the users will have to determine whether the system is a quality one or not based on their experience that they have interacting with the system. So what are some of the quality attributes? As you can see in this table, we have listed some of them here. You can see safety, security, reliability, resilience, robustness, understandability, testability, adaptability, modularity, complexity, portability, usability, reusability, efficiency, and learnability. All these are considered as quality attributes. In fact, some of them are not here. I can mention one of them that is called maintainability. We saw it earlier, but it's not listed here. Maintainability. How easy is it to maintain the system? That is maintainability. Okay. Now, so look at all these quality attributes. If you are working on a project and you want to achieve all these quality attributes, is it possible? The answer is no, it's not possible. Okay. That is why we have to think about fitness for purpose, right? Because earlier I explained that there's conflicts among some of these attributes. The conflict arises because if you are trying to achieve some of them, you end up compromising on some, right? So because of that, you want to think about fitness for purpose. And that means that you are only going to focus on those attributes, quality attributes that are actually needed in the product that you are building. Okay. Now, so how do we, but there are some attributes that are very important that you can't do away with. And what are some of those ones? I can tell you one of them is modularity. Why is modularity important? It's important because if you target modularity, you are able to achieve a number of these quality attributes. For example, modularity will help you achieve testability. It will help you achieve understandability. It will help you achieve usability, reusability, learnability, and what again? Even reliability. Okay, so that means that modularity is very important. So let me explain what modularity is. Now, in building systems, there are different approaches that you can use. Okay, some of them, there's one that we look at, we call it hierarchical approach. Hierarchical approach, okay. Now, it comes from the word hierarchy. That means there is an order, okay? It could be from, so the hierarchy means that from top to bottom or top-bottom approach, okay? So hierarchical approach to system building or development. What that says, what that is about is that, let's say you want to build a complete system, okay? This system is very complex. And so if you just start working on the whole system, you struggle, you find it difficult. In fact, that will make your work very complex. And anytime you are dealing with a complex system or complex problem, we want to have a way of solving that problem, or want to have an easy way of solving that problem. So building a system is a complex problem. So what do we do? If we want to use modularity, what we'll do is that we'll have to break this system into various components. Okay. So each component will become a functional unit that we can work on in isolation. So that means that in building the system, you are going to have various components, okay? And these various components, I'm taking, let's say this is here, the other one is here, and then this is here, okay? Now, that means that we are going to, instead of developing the complete system, we are rather going to develop various components that will later be integrated to get a system. And these components, sometimes some of them are also complex. So we need to break them down to have smaller units. So out of this, for example, this component, we can get unit 1, unit 2, unit 3, unit 4. So these units will also become smaller part of the system that you have to build in isolation. Okay? So now, when you build these systems in isolation, units in isolation, you test them to see if they are working fine in isolation. Then you integrate them to get this component. Integrate means you are adding them, okay, according to the plan that you have. So you integrate them according to the integration plan to get the components. And you do the same thing for all the components. And then once you get these components integrated, you are going to test them, the various components, and be sure that they are all working fine. Then you now integrate the components to get the system. If you use this approach, it becomes easier for you to understand the system. For example, if a fault occurs, or maybe after testing the various units and one is not working, you are able to isolate that problem, in fact, troubleshoot and be able to resolve the issue. You can localize the fault to this particular unit, okay? So it makes your testing, debugging easy, right? So then you are also able to understand the system from this perspective, because you know that, for example, let's say this is a calculator you are building, and one unit is doing addition, one is doing multiplication, one is doing division, another one is doing subtraction. If you have the system integrated as a component, and then you want to do addition, is not working, you know straight away that that problem is coming from the addition unit. So you can easily localize the fault, isolate the units, and then be able to resolve it and then integrate it back into the system. So it makes debugging, maintenance, and everything easy for you. So what is the word modularity coming from? These various units I'm talking about, okay? These units are referred to as modules, okay? Module. M-O-D-U-L-E, module. So these modules are the units, they are integrated to get components, and then components are also integrated to get a system. So it's a hierarchical approach to building a system, and it makes life easy when it comes to achieving many of these quality attributes. Any question about this? Hello?
Hello, sir.
Yeah, any question or comment?
Hello, sir.
Okay, so later when we are looking at testing, we're going to use the same concept, okay? When developers want to test systems, they start testing from the unit level, then they progress to the components level, and then once they are done with testing the components, they integrate them to get system. They have to test the system as a whole. Okay, so look at all these things when we are discussing testing as a topic. Okay, and so some of the attributes actually, as I said, can conflict with others. For example, complexity. Complexity is something that if we want to achieve learnability, we don't have to think about complexity, because complexity will make it difficult to learn the system. It will also make the system not easy to understand, okay? And it makes maintenance difficult, right? So that is how some of these things conflict. Now, so you know what this, let me try to explain some of these attributes so we can have idea about what they mean. So I'm starting with the reusability. Now, why is reusability? What is reusability? Let's say that you build a system, okay? As I said, that we're building a system using components, okay, in order to integrate them to get a system. Now, if you have these components, each component is a functional unit, okay? So in this system, you have all these components developed. Let's say another time you are developing a system and you need a component like this one in that new system. There's no need building a new component again, this one. You can just use this one in the new system that you are developing. It's a matter of using this one here and then building other ones in addition. So you have a complete system there. So that is reusability, meaning that a component can be used in other systems that you are working on or another person is working on, they can use that component. So if you really follow what is happening now in system development, you realize that most of the guys do not develop the systems from the scratch. In other words, they don't start everything by designing, coding, testing, and getting a complete system. No. Now, what some of the guys are doing is that they are reusing components, existing components in the system that they are building. So they have idea about the system they want to build, but they are also aware that there are components available that can be integrated to get their system that they want. So they go in for those reusable components. Some of them are off-the-shelf components. Once they get them, they test them, they do some sort of adaptation, get them integrated into your system, and find they have a complete system running for them. All right, so that is all reusability is. And it's possible because systems are developed using modularity. So we have unit, we have components available that you can reuse somewhere. It also makes life easy when it comes to portability. So portability is when you have a system that is developed and is used on a particular platform. Now, that system, in a way, can be adapted or maybe used on a different platform. Okay. Why? Because using this approach, it's possible to adapt and make that system be used on a different platform. So portability is also there. As I said, learnability is the ability of users or the ability that the users need to learn the system in order to use it. For example, if you develop a system that is not learnable, it will be difficult for users to use that system. Why? Because they are not able to learn the features and explore the system and be able to know how to use it in terms of navigating their ways through where to find this and all those things. All right. So that is what learnability is about. And then, okay, efficiency is a word that you all know. Which one? So I talk about adaptability, yes, to adapt the system and make it portable. I talk about testability, understandability. Understandability is when you can really study the system and understand how the system is working. Okay, so as I said, if you use the modularity, then the picture becomes clearer to you. You know what each unit is doing, and you know when they come together to form component, what each component is doing as a functional unit. So it helps you to understand the system and be able to work with it. All right, so that is that. Let's continue. So you can read about these attributes. Now, there are a lot of tools that can help in terms of learning. So you can use the AI tools to, if you don't understand a concept, you ask the AI, what does this concept mean in system development? It will explain it nicely to you. And all that. Okay, so let's go. So I explained what the conflicts is. Quality conflicts. There's conflict because it is not possible for any system to be optimized for all of these attributes that we have looked at. Why? Because if you are trying to improve, example, if you are trying to improve robustness that will lead to loss of performance. Okay, you want the system to be robust. But whilst you are trying to achieve robustness, you will decrease the performance attribute of the system. So because of this issue that I just explained, when we want to define the quality attributes, or in the quality plan, we should focus on the most important quality attributes for the software that is being developed. I explained that. So let's say we're building a system that we use for maybe a system that we'll use for authenticating students before they enter lecture halls. Okay. Then we'll ask ourselves, what are the required attributes? I mean, important attributes that we want in that system. So we're going to list them and focus on them instead of thinking about all the quality attributes that are available. No, we shouldn't do that. We make life difficult for ourselves because of these conflict issues. That we have to focus on the essential ones in that product. So because of this, your plan should include the definition of the quality assessment process. Any quality attribute that you want to see in the system, you need to document it and also show how you are going to assess the system for that quality. In other words, let's say you want the system to be reliable. Then you ask yourself, how do I assess that system for reliability? You need to document that. I'll do A and B to determine the reliability of the system. Okay, so that is the process you use to assess the product for that quality attributes. So there should be an agreed way of assessing whether some quality, such as maintainability or robustness, is present in the product or not. So process and product quality. As I said earlier, the process is used to develop the products. So that means if the process is not a good one, the product will also not be good. For example, let's look at ordinary or in everyday life. Okay. We know that if you want to cook, for example, if you want to prepare rice, there are processes that you have to go through to get that rice ready, maybe for lunch. Okay. You know, if you are going to cook for your one person or you are going to cook for a family of 3, you need to get a quantity of rice. You need to measure the water that you are going to use to boil it. You need to think about the quantity of salt you are going to add to the rice. Okay. Now, let's say that you get all these things right. Then you are able to get a nice meal or a nice rice cooked. However, if you get any of these things wrong, your rice will not be proper rice that people will enjoy. So basically, that is what we are trying to say here. That the process that is used to develop the system should be a good one, a quality one. If the process is not good, then you can't get a quality product. That is what this slide is saying. It said the quality of a developed product is influenced by the quality of the production process. This is important in software development, as some product quality attributes are hard to assess. Now, let me explain this. We know that product quality is based on the process quality. There's a relationship between products and process quality, because we know that if the process is good, we will have quality product. The attributes that we've been talking about, some of them are actually related to the process, and some are talking about the products. But we don't have well-defined relationship. In other words, it's difficult for us to understand the relationship between the process quality attribute and then the product quality attribute because it's not properly documented. Even though we have idea that the process will lead, quality process will lead to quality product, it's not properly documented for us to know the relationship between them. However, we can use this approach. As you can see in this diagram, we will define the process. That let's use this process to develop the system. Then we will develop the products. Let me explain something here. Anytime we talk about products, we are not only talking about the working software. A product in terms of system development could be the designs that we are producing. It could be the system specifications that you are going to produce. It could be the prototype of the system that you want to build. It could be the system itself. So all of these things are referred to as products. Okay? So you define the process, then you develop the products. Now, after developing the product, you have to assess the product for the quality that you're looking for. Once you assess the products for the quality, you ask yourself, is the quality okay? Okay, that is this stage. You ask yourself, is the quality okay? If the quality is not okay, then you know that the process is not good because the process you used to develop it should be a quality one for you to get a quality product. Once the quality of the product is not okay, then that means that the process is not good. So what do? We need to improve the process. Okay, so you improve the process, then you use the improved process to develop new products. Then assess the quality of the products, and then check whether the quality is okay. If the quality is okay this time, then you go ahead to standardize that process and say, because this process has given a quality product, this process should be the one that we're going to use to develop the systems. All right, so that will become the standard that you use to develop subsequent products. So that is the idea we can use to get the relationship between the products, the process, and then the quality, and the product quality attributes. Any question about this diagram? Do you have any question or comment about this diagram? Steven, do you have any question?
No, sir.
Okay. How about George? George, do you have any question or comment?
Not at the moment, sir.
Okay. All right.
Sure.
Okay, so let's continue. Now we talk about quality culture as against the detailed documentation for large and complex systems. I mentioned that if you're working on smaller systems, there wouldn't be a need for detailed documentation because that project may not take a long time to finish. And also you may not have a team living and you may not have some of the team members leaving and then for new guys to join the team. So there may not be a need for detailed documentation. However, you want to use quality culture. So in this quality culture, because everybody is responsible for the software development, part of the work that he's doing, they expect that each and everyone will be responsible for the quality of the work that they are doing. Okay. And they should take responsibility for the quality of their work. So that is what Agile guys practice. They believe that once people are aware of the right practices that they are supposed to carry out in terms of the system development, they are able to develop quality products at the end of the day. Okay, because quality is part of whatever they practice, right? So that is the culture, quality culture we're talking about. So let's look at standards. What are software standards? Or what are standards made for? Standards basically are the required attributes of a product or the process. So whatever attributes that is required of the product or the process will become the standard that will be documented in the quality plan. And they play an important role in quality management. Now, with these standards, it could be international standards, it could be national standards, or it could be the organizational or project standards, depending on the standard you're looking at. Okay. So what is standards important? If it is important, what makes it important? They are important because they encapsulate what we call best practices. Okay. Best practices are things that people do to get good results in terms of whatever they are doing. Okay, so when it comes to software development, there are practices that if you engage yourself in those things, you're going to get quality products. In other words, these practices will help you avoid repetition of past mistakes. For example, let's say that if you are writing a code and you forget to check or implement what we call input validation, and then you release that system and the system is being used. So somebody comes to use the system and enter the wrong inputs. What is going to happen is that that system will crash. Okay. And if the system crashes, you learn in the process and say, hey, next time when I'm going to develop a system, I need to implement, I need to validate the inputs that people will be entering into the system, or the input that the system will accept from users needs to be validated. Okay. So that will become a best practice for you that you can share with people. Now, what that means is that anybody who will learn or practice what you have shared as best practice will avoid making the same mistake that you made and then you learned from it. All right. So that is what we mean by best practices. The standards are encapsulation of best practices, and they help to avoid repetition of past mistakes. Standards are also defined. Standards are a framework for defining what quality means in a particular setting. For example, in a typical organization, typical development organization, they will have their own set of standards. That is to say, the things they want to see in the products. They're going to list all those things and say, we want this, we want to do. For example, in terms of the process, they will say, this is how we are going to design our systems using this technology, using this approach, using this tool. Those will become the standard. When it comes to writing code, we have to use this language, we have to use this editing tool, we have to use this. They will state all those things. So in that setting, in that organization, that is their standard. And it will not be the same as what you see in a different organization. So that's why we're saying that the standards will become a framework for defining what quality means in a particular setting. That is that organization view of quality. Standards also provide what we call continuity. Why? Because when new staff join the company or are employed, they need to understand what the team has been doing and also follow suit. Now, if people are doing things haphazardly, in other words, everybody is doing things the way he or she wants on a project, then that becomes difficult if a new guy joins the team and he has to work with them. Okay. But if they have standards, then it's easy for a new person or a new staff to understand them and also follow what they have been doing. For example, let's say that we want to write, let's say I give you an assignment, okay? Or let's say we are working in a company and I'm the project manager. And I want you to develop a system. And this system, I specify that, look, let all of us use Java. Okay, that is our standard. Then it's easier for people to understand themselves. So if John is writing a code, Collins will be able to understand what John is doing. Okay, and Collins will also be able to understand what George is doing. So that is what we're looking at as standards. Now, if a new person comes or a new person is employed in this organization that we are working in, then that person knows that, okay, they use Java. That is the standard. So I have to learn how to write code in Java to be able to work with this team. So basically, that is what we mean by it provides continuity. Okay. So product and process standards. As I said, there are standards that are relating to the product and some are relating to the products. So the product standards apply to the software products being developed, and the process standards are standards that are relating to the process that is used to develop the system. So as you can see here, for the products, they include things like document standards, such as the structure of the requirement documents, documentation standards, such as standard comment header for an object class definition, and coding standards, which define how programming language should be used. All these are relating to product standards. Then when we talk about process, we're looking at process standards may include definition of specification, design and validation processes, process support tools, and a description of documents that should be written during these processes. Okay, so the process standards are related to the processes and product standards are related to the software product that is being developed. So examples are here. You can see for products standards and then the process standards. Examples are design review form for products. They also are requirement document structure. As I mentioned, Java programming style, project plan format. These are examples. It doesn't mean that it applies to every team that is developing a system. It depends on what you are working on and what you want to use as your standard. Okay. Somebody may say, instead of Java, somebody may say C++ style or PHP style. I mean, it depends on whatever you are doing. Okay. So what are the problems with standards or the use of standards? Some people think standards are bureaucratic. What that means is that because it involves form filling, it's kind of waste their time. Okay, instead of focusing on building the system itself, you have to be doing paperwork and checking things, documenting things, and all that. That's a kind of bureaucratic form filling is what they don't like about standards. Others also think that standards may not be seen as relevant and up to date by software engineers. Okay. And others also think that it's tedious if you are not using software tools to support the standards that they are supposed to apply. Okay, so three things here. The software not being relevant because it's not up to date. It's bureaucratic. It involves form filling. And then not supported by software tools. That's making it tedious to practice. So these are some of the problems people have documented. Now, so how do you overcome these problems in using standards? So if you're going to get standards in a particular environment, development environment setting, you need to involve practitioners in development. In other words, people who have worked on similar project before, who have experience, can share their insights when it comes to the kind of things you should use, the kind of practices you should adopt as standards. Okay, so people like that should be involved in developing your standards. And these standards should be reviewed regularly because we just saw that people raise issues about the standards being obsolete. In other words, not being up to date. Therefore, it will not be relevant for the work that they are doing currently. So if that is the problem, then any standard that is adopted needs to be reviewed regularly. Okay, so that is that. And also, standards should have specialized tools to support their implementation or usage. So these are some of the things we can do to avoid or minimize the problems that have been listed here. Any question, comments? Hello, comments, question?
Oh, sir.
So we're supposed to end at 4:30, right?
Yes.
Okay, so let's take a 5-minute break. We'll come and continue from here, ISO 9001 standards framework. 5-minute break, so people can stretch yourself, or you can drink water. You can stretch yourself, and then we'll come back to continue.
3:30.
Sorry?
It's 3:30. Oh,
We are ending at 3:30?
yeah. The next class starts from 3:40.
Oh, okay. Are we not doing 3 hours or it's 2 hours?
2 hours.
Oh, okay. Then we don't have to take a break because it's almost it's 3:40 now. According to my watch, it's 3:14. Okay, so we've been looking at standards. And we've seen that standards can be international, can also be organizational, can be national. Okay. Now, I want us to look at international standards, what is called the ISO 9001. ISO means, it's an acronym. Tell us what ISO means. ISO, this is a common acronym that we all use. So somebody should tell us what's the meaning of ISO. Is there anybody here who can tell us? Desmond, what do you think ISO means?
Hello, sir.
Yes.
So this is a international organization for standardization.
Yeah. Or International Standard Organization. You know, some of these things are because of the French-speaking countries, they have a way of framing it. Okay, but it's the same thing. Now, in every industry, you will find one or two standards that guide them in terms of what they do. Okay. When it comes to IT and telecommunication, we also have certain standards. Okay. Now we're looking at developing a system, and we're looking at how to achieve quality in that system that we want to build. So we need standards. Some of these standards, I said, can be national, can be international, and developers or users expect that whatever products you are going to give them is actually meeting these standards. In fact, some organizations that you want to deal with will even require that you are certified by some of these standard organizations in order to patronize your product. So it's important that we are aware of these things and then be able to comply so then you don't have issues. Now, so let's look at ISO 9001 standard framework. We talk about framework because it involves, it's kind of guide developers to write their own standards in terms of what they are doing in their organization. Okay. It's like a guidelines that are given, documented guidelines that will help you write your own quality standards for your projects. Okay, so that is the idea. So this is an international set of standards that can be used as a basis for developing quality management systems. If you want to develop quality management systems, then you can use these standards. ISO 9001, the most general of these standards, applies to organizations that design, that develop, and that maintain products, including software. So it's a framework for developing software standards. Okay. So how do we use it? It has different aspects. As you can see, there's product delivering process and then supporting processes. So you can use the business acquisition, design, and development, blah, 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 blah. This is not important to me. What I'm interested in is this. How do we apply it to our work or anything that we want to develop? So as I said, this would be like guidelines for us. It's not like you are going to use them. Yes, no. It's like to guide you. Do this, do that, blah, blah, blah. Okay, so we'll look at this quality models. So that will become, the ISO 9001 will become a model for us. Then we'll create our own organization quality manual based on the ISO 9001 quality models. We'll create our own, which is the organization quality model manual. Now, this manual will now guide us. You know what? We talk about 3 levels where we were looking at the concerns. We talk about management and then project level, that the management will establish the standards and procedures in terms of the quality that they want. Then at the project level, they will adopt those standards and apply them to the projects. And that means that at the project level, they will have to write quality plan. And the quality plan is based on those established standards and procedures at the management level. The quality plan will contain quality goals and how those goals contain quality goals and the standards, and also how the system will be assessed for the quality attributes. Now, so if you look at this, you see that based on ISO 9001, the organization can create its quality manual and then use the quality manual to write quality plan for each project. So you can see for project 1, there's quality plan, project 2, there's quality plan, all based on the organization quality manual, which is also based on the quality models in ISO 9001. Okay, so basically that is what I want us to learn from this. Now, somebody will ask, why is this necessary? Why is it necessary to think about creating your quality manual based on ISO 9001 quality models? Okay. Now, as I said, some organizations or some customers will require that if you are going to develop a system and supply it to them, you are ISO 9001 certified. Okay. You are certified. Then they know that whatever you are doing, you are actually conforming to some standard that they trust, they believe once you achieve that standard, they can trust that your system is a quality one. Okay. It's just like in Ghana, when people are producing in the industry, people are producing all sorts of things for us to consume, like the drinks, the food stuff, the package for us. Then people will be asking questions whether these things are really certified by Food and Drug Authority. Okay. Why? Because they believe that if Food and Drug Authority has seen what they are doing, has approved it, then it's good for us to use. Okay, so that is the idea that if even in terms of system development or any product, once you have certification, it means that you are actually achieving some level of quality in the product. Therefore, people can patronize your product and use it. So that is the same thing we are looking at here. That some customer will require that you are certified by ISO 900 using ISO 9001 standard. Okay, so quality standards and procedures should be documented in an organizational quality manual. That is important. So an external body may certify that an organization's quality manual conforms to ISO 9001 standard. And as I said, some customers require suppliers to be certified. Okay. Okay, let's jump this one. I just talk about the certification, meaning it's adequate resource defined quality to be conformance to standard. It takes blah, blah, blah. Now let's look at reviews and inspections. Now we've seen what quality is in terms of definition. We learned that quality can be defined in terms of the specifications. And we also learned that using specifications can be problematic because there's conflict between the various attributes. And also the fact that some specifications sometimes can be incomplete and inconsistent will make it problematic. Therefore, we should rather think about fitness for purpose. So we saw what fitness for purpose means. It means that the system has to be tested for dependability, testability, understandability, and all that. Then the system is fit for purpose. That means that you are going to focus on some quality attributes that are really needed in that system. Then we saw other things that we've discussed. Now we are at the point where we have to think about assurance. How do we assure or really get the work done in terms of achieving quality in the system. So we want to look at reviews and inspections. Now, these are things that we can do to actually get the errors, the defects that are in the system and get rid of them. Okay, but before we look at, okay, so in assuring quality of a system, there are different strategies or activities that you can actually engage in, and some of them will be discussed later. For now, we want to look at reviews and inspections. So when we talk about review and inspections, what are they? During the development stage, the development team is building the system. You remember we saw the diagram where the development process is going on and the quality assurance team is also doing their thing, reviewing whatever deliverables they are producing. So that means that at every stage of the system development process, the deliverables will be checked, and then they will be sure that they are meeting the standards. Once the quality team is okay with whatever has been produced, they will have to give the development team the go-ahead to continue working on the projects. Basically, that is all reviews is about. So a group of the quality team will examine parts or all of the processes, all part or all of a process or system and its documentation to find potential problems. So as we saw, they can look at some of the deliverables or all of them to see if they can find issues, identify some issues in there. If they don't identify anything, they are okay with the work that has been done, then they will sign off. Software or document may be sign off. Sign off here means that they have approved the work, and that means that they are telling the team to progress to the next development stage. Okay, so sign off basically means approval of what has been done and to continue to work on the project. Okay, but before we think about reviews and inspections, we need to think about the goals or objectives. What do you want to achieve when you are going to review the deliverables? You need to have the objective that will guide you. Okay, and there are different objectives you can think of. For example, you can do inspections for defect removal in the products. Okay, you can also review for progress assessment to see how the project is progressing in terms of the product and the process. You can also do quality reviews for the products and the standards. So this will be your objectives. Once you know your objective, you adopt certain strategies, practices that will help you achieve the objectives. So let's say that we want to do quality review. So for quality review, as I said, you have a group of people. Let's call them the quality team. Okay. So this quality team will carefully examine parts or all of the software systems, call them the deliverables, and its associated documentations. For example, the code, the designs, the specifications, the test plans, the standards, all these things will be reviewed. Okay. And once they are okay with whatever has been done, then they sign off. And that means that the team can continue to work on the rest of the, progress to the next stage of the system development. Okay, so that is what sign off means and review means. But the review has a process that they have to follow. So this process is in phases. Okay, so the phases, we can divide them. Okay, the phases are three. We have pre-review activities, then we have the review meeting, and then the post-review activities. So the first one is the pre-review activities that they have to perform. And during this pre-review phase, the team will plan and then prepare. So there is review planning and then review preparation before they go into the meeting, review meeting. So once they are prepared, they go into the review meeting, which is the second phase. And during this meeting, the developers will meet the quality team, okay, and they walk them through the documents, okay, so that the development team will walk the review team through what they have done, in terms of documentation. And at this meeting, the team may discover errors, defects, or something that has been left out, okay? And they will point those things out. Once they are done with the meeting, they go into the post-review phase. That is the post-review activities. So at this stage, the development team will have to address the issues that have been identified during the meeting. Okay, so that is what is done during the post-review activities. They address the problems and issues that have been raised during the review meeting. So this is what review process, this is how the review process looks like. They have three phases: pre-review, the review meeting, and then the post-review. And each phase has specific task. All right, so that is how it is. So we can look at it in terms of this diagram that I'm showing. I hope you all seen the diagram. Hello, can you see the process?
Yes, sir.
Okay, I think it's time, right?
Yes, sir.
Okay, so let me just explain this one, then we'll end it here. Next week, God willing, we'll continue. So, as I said, it starts with the planning and preparation. So during the pre-review activities, the group will plan and prepare, and then they go to the second phase, which is the review meeting. But before the review meeting, the individual preparation will take place, and they have the review meeting. This is where the issues will be identified, okay, as the development team is explaining the work to the review team. They are able to spot issues and then they raise them. But they don't address them during the meeting. It's after the meeting that they go into the post-review phase, and then they correct the errors, and then they improve on the system, and that is it. Then there'll be a follow-up. That means there will be another review. Okay, so basically this is what happens during the review process. Any question, comments about what we have discussed or what I've explained to you today? Otherwise, we'll have to end it here. Any question, comments? Stephen?
No, sir.
Yeah, any question, comments? Okay, so let me ask. Yeah, the other lecturers, are they give you the slides, or you just have to depend on the course model?
They give us the slides.
Lies.
Oh, okay, all right. So then, you can send me your email. I'll share with you, so share. I'll share all the slides with you. Even those
Okay.
we have not discussed. I will let you have all so that you'll be going to us. We discuss them from time to time.
Okay. Sir,
So
please can you upload it on the LMS?
okay, that's fine. That will be Monday because I'm yet to have access to that system. Even though I have access to the general system for the distant learning platform, I'm yet to
Oh,
familiarize myself with it. So that will be Monday.
okay.
All right. Okay. Then see you. Enjoy the rest of the weekend.
You too.
Thank you
Thank
too.
you.
Yes, sir. Thank you.